Okay, hello everyone. So yeah, welcome to the session, Securing MQ, or Securing Your Messaging Network. Now, a lot of these sessions have kind of been focusing on one technology. I really, when I submitted this talk, wanted to try and be very broad and talk about just security in general. I love security, which I guess is good, given that you're the security architect, but obviously entrenched very much in IBM MQ. As this slide will tell you, I've been in MQ, or IBM MQ, for about 13 years now, and been doing the security architect role for about the past 8 or so. So I'm responsible for the design, development, research around security and implementation into MQ. So if you have seen any security features you like in IBM MQ, come and tell me. I'd love to hear you, because no one ever tells me if they like a security feature. They always tell me if they don't like a security feature. So come and tell me that as well, because I'm always open to feedback. But please, I'd love to hear some positivity for once. So this session, what I want to do is I want to try and just talk about, kind of ask or hopefully at the end you'll have 3 questions that you're able to answer. And I'm sure the first one is probably very easy and everyone already knows the answer of why we secure. Probably everyone knows roughly where they would want to secure in a messaging broker, and then maybe there's some understanding about how we secure. But hopefully we'll be able to point out some areas that I've found that are almost like areas where customers forget that they need to focus some security assets into. So hopefully we'll come out with some lessons. So why? Why do we secure? In my opinion, data is kind of like cake. Everyone, or 99.9% people like cake, and everyone loves to have a slice of cake, and people do different things with cake. Some people eat the cake, some people ship it off somewhere, some people sell it on, some people even sit on cake, and we don't talk about those people. But ultimately, data is like cake in that sense, because to an attacker, your data is something that they're going to want to take, whether they consume themselves to use as an advantage, whether they sell it on, whether they sit on it and use it as blackmail for you, but it is something that they themselves want to gain access to. And as messaging products, we deal with transferring data. So we're a prime target for attackers. And because of that, I'm sure that we can all agree, security is vital. Now, the whale is breaching, because if you have a data breach, there's some statistics that we can rattle off here. So IBM every year produces a report for what it calls the cost of a breach. Now, the numbers on here are scary because they're the global averages. So if you're a small company and you're looking at, not anywhere near the profit margins of 4.44 million, don't be worried if you have a data breach. You're not going to get fined 4.44 millions. It's obviously global average. So when a massive global company gets a data breach, their fine is going to be proportional to their income. But this is the average cost of breaches across the world. The average cost of a malicious insider attack is actually more than just a data breach. But these are, if you have a data breach, it's costly, not just from the financial side of things, but also from the reputational side of things. I'm sure if we think, okay, who's had a breach recently and what did it do to their reputation? In the UK, we had a large retailer got hit by a data breach. Now, it maybe wasn't caused directly by them, it was used by one of the third parties that they were using, and I'm not going to name names here. You can easily find out who it is if you want to do a quick bit of Googling, but anybody in the UK knows about that because they were hit by the data breach, it impacted their services, and then on we went with there. One of the interesting things that I want to come back to later is this bit here, which I didn't realize and found out from reading the report. 1 in 6 breaches nowadays are using AI. So keep that in mind for a little bit later. Now, that's the why. Why do we secure? We secure because it's costly if we don't. So where do we secure? And I've come up with this variation of, here is an abstract messaging network. We've seen many of them today with different symbols and different representations, but ultimately it's box, arrow, box, arrow, box. And in this case here, we've got producers, we've got consumers, we've got a bit of clustered brokers in the middle, we've got even some disaster recovery or HA, depending on what you want to see it. But where should you secure when you're looking at this? And the answer is everywhere. Right. that's going to be quite difficult to do. So let's actually break it down rather than just say the answer is everywhere, close the sessions and take questions from that point. Where should you focus your efforts? And the first place that I think generally most people start looking at securing is the actual brokers themselves. And when we're saying about securing the brokers, what we're saying about securing is doing both authentication and authorization. Now, they are two distinct things. Authentication is where you say, I'm going to prove who you are. Authorization is where you're saying, I'm going to let you do what you want to do. Everyone always bundles them up together. So it's always, okay, yeah, who you are and what you can do. But they are two distinct things, and there are distinct ways of doing or implementing authentication. IBM MQ is obviously one of them. We've always had many ways of authenticating, but so are all of the other products. And there are all different ways of authenticating to each of the different products. The nice thing is with security is there are patterns that most people kind of fall into. And the patterns that exist is that most, if not all, of the providers form some way of connecting to brokers and providing credentials as a way of authenticating to them. So this can be a username and password, which is then checked against either the operating system, or checked against an LDAP registry, or checked against a IAM service that is actually part of the service where the messaging process is running. There's also other forms of credentials like Kerberos, and I'm going to skip to the very last one, OIDC and OAuth, which are token-based. Kerberos maybe not, but OAuth and OIDC are token-based. So this is a new form of authentication that's starting or has been coming out. MQ and a number of others, which I can't remember, have integrated a form of OAuth 2.0, which allows you to do authentication where you're actually using a third party in order to provide the authentication, and then what you actually get is a token, or the broker gets a token that says I am who I say I am as per this person over here. So added layer of complexity, but it encourages centralization of authentication, which is always good, and also removes the need for the broker to receive the user ID and password and do validation of it, because the user ID and password is generally seen as crown jewel, or at least, if not crown jewel, very important. Now, the final form of authentication that most of our providers or most messaging products implement is TLS. We've heard it mentioned. Two-way TLS, it's sometimes called, mutual TLS, but this is an implicit trust between both or not implicit, a trust system between the broker and the application and the broker using TLS. Great. This means that you can use if you're using TLS, which the next slide will show that you should be, you will be able to use that in order to basically authenticate as well. Now, once you've authenticated, everybody implements some form of access control list. They call it access control list or policy or something like that, but that just denotes what they authenticated identity allows you to do. Some services, like maybe OAuth 2.0, actually wraps that together. Both the token that comes across says who they are, but also says what they're allowed to do, and so you can wrap all of that together. But all of this is around authenticating into the brokers, applications into brokers, or brokers to brokers. Now, after you've secured your brokers, you need to secure the communication lines. And this is where TLS comes in. TLS protects data in transit. It's there to encrypt and do integrity checking on the data as it flows between your brokers and your applications, or your brokers and brokers. It's a standard that's been around. I'm sure nobody needs an explanation about what TLS is, but TLS, every single one of the messaging providers integrates it. What they don't integrate, or not all of them integrate, is some form of certificate management system. And for the talks that I've had with our customers, and I'm sure people have experienced as well, the real pain point about TLS is the certificate management part of it. Certificates have a set lifestyle. Most, up in recently, generally it was a certificate expired every year. I believe Google were pressing for certificates that expire every 90 days, maybe even quicker than 90 days. So a certificate management system should maybe be built into a messaging system as well, or at least built into anything that's doing TLS, because having that in place enables us to actually potentially have a system which allows quick quick refreshing of certificates where needed. And there are, of course, many certificate management systems or encryption as a service systems out there, or PKI systems, which you can use with other products in order to try and smooth over that gap. Now, TLS authentication, two areas everyone probably already knows. So let's talk a bit more about areas that I see people who are forgetting about. And that's data at rest. Now, if you're not in an industry that requires you to do this, I think most people forget that actually, we're talking about data being cake, and data across a line, fine, you've used TLS to protect it, you've stopped people getting into your brokers, but the data is going to sit somewhere at some point. It's going to be a message on a queue. It's going to be an entry in a database. It's going to be somewhere. If that's not the final destination of that data, do you need to just leave it in plain text? And the answer to that question is, well, it depends on, as with most things with security, it depends. It depends how paranoid you are about whether you care. Now, if you care enough that you think, I don't want that data that is at rest somewhere to be read, there's a few options around. And, generally, disk encryption is supported elsewhere, especially if it's transparent to the underlying or to the messaging system. The problem with disk encryption is that protects you from someone stealing the disk. So a lot of cloud-based messaging products have the ability to say, I would like a piece of storage, and can you make sure that storage is encrypted? Great. No one outside of the you in that sense could come up to the disk, take it, and read any of the data on there. But if somebody gains access to the operating system, for example, if you've got a message broker running on a Linux server, you've encrypted the disk, but someone's able to log in or gain access or create a remote shell to that system, and is then able to just mount the file system somewhere in the correct way. They've stolen credentials. They can now read that data even if they weren't supposed to be able to. File system permissions maybe does something to protect you in this space. But again, if they've found a way to subvert that, if they're overcoming this, then is that enough to protect the data? Maybe instead you want to do data encryption, end-to-end data encryption. So in this case, there's a few products out there that support something in this space. They allow data that is being created by the producers to retain protection all the way across until it's received by the consumers on the other end, and at that point it will be decrypted and read only by the consumers. So no matter where that data goes or lasts, it will retain the encryption until it's removed. And as I say, there's plenty of products that do that, and of course, encryption is actually getting easier to the point that if you don't have a product that can do this, if you're in control of the applications, then things like HashiCorp's encryption as a service could be a way of implementing this at the application layer instead. One other thing that people assume is not security would be high availability. If we look at the CIA triad, and CIA is not the American industry, not industry, the agency. CIA is the CIA triad is the security architecture or architecture principles that you should be using when designing security, which stands for confidentiality, integrity, and availability. Well, high availability should be baked into your security mindset, because if you assume, no matter what I do, at some point I'm going to get attacked and they're going to take my service offline, you need a backup, because this is what happened to that large retailer in the UK. Is they got attacked in a way and it took a load of their services off. Now, it's not going to protect you all the time. Sometimes you can't rely on this entirely, because if you go, well, it's fine. If I get attacked, I'll move from site A to site B. But then that doesn't help me because site B is also compromised. So now I can't go from site B to site A because I'm just flip-flopping backwards and forwards. It's maybe what happened to the UK retailer. But having this idea that you need the ability and testing the ability to fail over across sites is important to retain services in the event that you get attacked. And this is another piece of security that people occasionally seem to forget. The next bit of security that I see people forgetting is, again, on the lines of assuming you will be breached. If we think about zero trust, so hands up, who doesn't know about zero trust or the principles of zero trust? Okay, good. A couple of hands. That's good. So zero trust principles are a couple of security designs that enable or basically encourage you to come into this with the idea of, funnily enough, trusting nobody. Zero trust. What it asks you to do is it says, well, when you're authenticating and authorizing someone, you should grant them least privileges. Assume that when they come in, they're going to be malicious and try to do things you don't want them to do, so therefore you should only grant them the privileges of things that you want them to do. Another principle of this is to always assume that you are going to be breached, or you have been breached, in which case you should always be watching what anybody connected is doing. Because if you go down that route, whether you're breached by an outsider who comes in and does something, or an insider who has decided that he's got pretty annoyed with your company and actually wants to go off and do something to harm your business before security gets to his desk and drags him from his keyboard and throws them outside the building, you need to know what they did in that time frame. The other thing about this as well is that from my very brief experience into penetration testing, a lot of what attackers will do once they've gained access to a system is nothing. Absolutely nothing. They'll get into a system, they'll sit down, and then they'll just watch. They'll wait, they'll listen, they'll watch what's going on, they'll get an idea of what's going on, and then they'll start trying to make tiny little adjustments here and there. We all have a variety of different tools in place to try and detect if there is an intrusion. But if those tools aren't going off, then the attacker is going to do things to see what they can probe and what they can do without that tool going off until the tool goes off, and at that point they'll open the floodgates and see what they can get away with before they get kicked out. And that's the danger point, is when they're doing things that are not causing alarms. You need to, once an alarm has been done, so once you've detected them and kicked them out of the system, go back and see what they've been doing. So we're talking about auditing here. We're talking about keeping a constant log of this is what this person did, and then being able to come back to it later. So if you go, actually, they were not who they said they were, they'd just stolen the credentials and impersonated somebody, and they've gained access to my system, and I now need to go and see what config changes they made or what they've accessed so that we can go and inform our customers and various things like that. You need to be auditing both the cases where you have blocked someone, but also where they've been successful, so that you can go back and replay that and potentially undo some of the damage that they've done. Also, very important, because then you can find how they got into your system and hopefully patch that hole. And then finally, not finally, I don't know why I've said finally, I can see how many slides I've got left and we're not there at all, but I'd say finally the biggest thing, I've said it again, but finally the thing that I find the biggest challenge from customers from speaking to them is security agility. To the point earlier about the first thing you should do is set up security. 100% agree. Setting up security should be the first thing because it is easy to change. It's hard to change later. The second thing you should be doing is adding in the ability to change it, because I see and have conversations with customers who turn around and say, we bought MQ, we implemented this whole system, we turned on security, we got it all working, and then we stepped back and went, cool, that's done, on to the next thing. And that was 5 years ago. And I haven't touched it since, and technology's moved along, and I pointed out earlier about the breaches. 1 in 6 are now using AI-driven attacks. So in this case here, I chose this slide for a very specific reason. You're the front guy. Your business is trying to stay ahead of the guy at the back who is attackers learning new ways to breach your system. So it is security is not a done and dusted. It's not an implement it and just call it a day. It is an endless race because there are new attacks coming out, new vulnerabilities. Outside of course, the attacks, there's things like new regulations and technologies every time. Do you want to be continuing to use OS-based user ID and passwords, or should you actually be looking at OAuth 2.0 or moving on to mutual TLS? Perhaps mutual TLS is going to change. And in fact, it might do, because of course there's quantum computers around in the future. So quantum computers can potentially blow up TLS. So if you've decided that I'm going to implement TLS 1.0 and just call it a day there, well, 1.0 is over, so don't implement 1.0. 1.2 is still okay, but really you should be on 1.3, because 1.3 is where the new quantum safe algorithms are going to be coming into. But all of this is, if you have baked security in so hard that you can't change it later, this is going to be a sticking point for you. Now, not a problem that I hear with customers, but there is a question that I do hear quite a lot from customers, which is, okay, fine, you've got all of this choice for security, and this is, I'm sure, not something that you don't hear in other messaging products, but I've got so much security, how much should I turn on? And I said earlier, everything. And the answer is not everything, but there is no answer for it, because it's an endless fight in terms of you want to make sure you have enough security in order to be able to stop an attacker coming in, but you don't want to spend your life doing security, hence why you should try and have automated processes that do it. But one of the challenges that we see from our customers is the sheer volume of regulations that are coming out and security standards like PCI DSS, SOC 2, ISOs, things that are coming out nowadays around quantum. So in a messaging space, it's very easy for us to just say, okay, well, we'll implement a few security features and maybe we'll tell you how to implement them, but otherwise, good luck to your customers. We'll help you where we can, but we're not going to do anything. And as a kind of mini call for collaboration, perhaps there's something better in this space that we can do as messaging implementers. Is there a way that we can either define our own messaging security standard that can then be implemented, or is there something that we just need to be individually better at, saying, okay, well, here is how you make Rabbit MQ or SQS or Microsoft Simple Q or IBM MQ, or keep going for every single one of the implementers. This is how you do the PCI DSS one. This is how you do it for SOC 2. This is how you do it for ISO. Here's how you make yourself quantum safe, blah, 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 blah. Keep going. So it's an interesting one, because it would be great to collaborate on anybody that would be interested in looking at how we can be better at standards or security standards in a messaging space. Now, I think I've got bang on 20 minutes, which I think was how I managed to time this. Was impressive, because I got worried halfway through that I was just rambling. So, conclusions. I thought I had 3 lines in there. Sorry, back we go. In conclusion, this has been a whistle-stop tour of a number of different security features, including what I've seen in the past as being sticking points for customers. I'd love to have conversations with people about security. Again, as I mentioned at the beginning, I've been doing it for 8 years and I don't plan on stopping. I do really enjoy it. And the nice thing is, with it being such an evolving space, is I don't really see myself as being out of a job anytime soon. So I highly encourage people to look at security. It's a great area to be in. It's got lots of challenges. But I'd love to work with more people in the messaging space. You know, I live inside IBM MQ, but I'd love to actually talk with people outside of IBM MQ and get an understanding of how products are doing it, and see if there's common ground that we can have there, because it's always good to work together. With that, there's a lot of thank yous, and I will apologize if I have completely got the wording wrong for any of those languages. I did use Google Translate, and we all know how trustworthy that is. So thank you very much.
Thank you, Rob. We've got time for some questions. Any questions for Rob?
I loved your idea about collaboration in the messaging space, especially with the message data in flight. So when like encrypting the data or the message itself at rest, I think an opportunity there might be to come up with a standard to identify, hey, this message is encrypted, and then kind of agree on, you know, a way that you could encrypt it with one producer on one platform and pull it off on another, because these things tend to get passed around. So yeah, I'd be all for that.
That's great, and I agree. So IBM MQ, again, I wanted to keep this as broad as possible, but we will narrow down for a little bit. So MQ for IBM does offer feature that does do this, but it is entirely specific to MQ. Yes, it uses a open security standard of PKCS 7 in order to do it, but the way that we create the message means that if we were to send it through MQTT or AMQP, we'd have to remove that protection before we flowed it through our MQTT or AMQP broker, either direction. So at that point there, it's not really end-to-end because it's the end is the edge of the IBM MQ boundary. So yes, I agree. It would be fantastic to have some standard to go, right, Rabbit MQ over here, forward it in, and it goes across to our MQ for our connector, but it retains that protection all the way to the other side.
Questions/comment. We get in cloud events, which is one of the standard things. We get quite a bit of questions, and then the occasional proposal to do kind of an end-to-end security signing solution. And I'm always trying to say thank you, but no, just because of the complexity of it. And so I would find it fantastic if we found a way to take something. I'm going to say something terrible, something like SMIME, and kind of apply that just universally to the concept of messages, and so that we can go and kind of build a standardized story that kind of works cross protocols.
Yeah.
So that we can go and basically just standardize what that metadata needs to be, and then payload is payload, and that goes encrypted and signed. So that would be fantastic if we could go and find a forum where we can go and talk about this and do it.
Yeah, yeah, it would be great. And I see one of the biggest challenges, of course, key sharing. But there are people out or technologies out there that are already trying to solve that. For example, if we look back at OAuth 2.0 and OODC, in order to share, if you want to do token validation at the area where you're consuming the token, you obviously need the appropriate key to do that. And JWKS allows you to obtain the keys from the identity provider. So yeah, but if we can solve that and the other complexities, then that'd be great. I think there was a question just over here.
Yeah, a bit of a follow-up on the first question. You said that you needed to decrypt the message for it to go through MQTT, AMQP conversion. So are you encrypting the whole frames or not just the message body part?
So in MQ, we encrypt the message body, but not the properties or the payload data. Sorry. Payload, we encrypt the payload, but not the message properties or the header. Sorry, wrong word. But we wrap the whole thing up in our own special MQ gibberish. And that's the bit we have to remove. So we could, in theory, remove the MQ gibberish and keep it as a PKCS 7 blob and send that through the link. But as you say, we need ways of also sending the metadata that we store in part of our MQ gibberish in order to send that across so that when MQ gets it later, it can remove the protection. Or more accurately, if we transfer that into an open standard, whatever's removing that protection later can remove the protection.
Awesome. Thank you for answering all the questions. Let's give Rob one more round of applause.
Brilliant. Thank you.